Okay, here we are solving proportions with equivalent ratios. So this is very similar to what we just talked about in terms of setting the proportions up as two equivalent fractions and kind of seeing what you multiply or divide your numbers by to get the other fraction. So it's better explained by just doing. So one way that we could go about this is, let's rewrite this. So x is what we're solving for, so x over 7 is equal to 15 over 21. Well, what am I, of the numerators or denominators, which one do I have both? Or which one isn't the unknown? So our x here is in the numerator, so that means I know what my denominators are, right? What's the relationship between them? How do I go from 7 to 21 using multiplication, not addition? Well, it's going to be times 3. So that's our multiplier that we're going to use for the numerators as well. So what we have is, we know 7 times 3 is 21. Well, what times 3 is 15? Well, this what is our x, so what times 3 is 15? It's 5, so x is going to equal 5. The other way that we could do this, very similar, but just going the other way around. So I'll have x over 7 is equal to 15 over 21. If I go from right to left with my denominators, because I'm given those two, might as well start with what's known, not what's unknown. Well, 21 to get to 7, we're going to be dividing by 3. So if I'm going right to left, from that 15 to x, I'm going to divide by 3. So the new question is 15 divided by 3 is what? And again, this what is our x. So 15 divided by 3 is 5 again. So a couple different ways of using equivalent ratios, using either multiplication or division. One other way worth noting is that if you can simplify the fraction that you are given, you should just go ahead and do that. So I got x over 7 over here, 15 over 21. I can divide both of those numbers by 3. So if I divide 15 by 3, I'll get 5. And if I divide 21 by 3, I'll get 7. Well, look at this. Our numerators are the same. So since this is a proportion, two ratios that are set equal to each other, if my denominators are the same, that means my numerators have to be the same. So x is going to equal 5 because that's what our numerator is over here. And this matches exactly what we got for those two methods there. All right, some examples. Let's look at the first one. So over here, I know what my numerators are. So let me see if I can find a relationship between them. So 3 times what is 30? Well, that's going to be times 10. So that means I'm going to do that at the bottom as well. So 4 times 10 is going to give me x, which means x is equal to 40. All right, x over 5 is equal to 11 over 55. I'm given my denominators, so let me see what the relationship is there. 5 times 11 is going to be 55, so I'm going to multiply x by 11 to get this 11. So what number times 11 is 11? That's going to be 1. X equals 1. And I can write these new proportions just so you can see that they are equal to each other. 1 over 5 is definitely 11 over 55. And then the one before, 3 over 4 is definitely equal to 30 over 40. All right, 7 over 9 is equal to x over 36. I'm given my denominator, so let me find that relationship there. 9 times 4 is 36. So I'm going to multiply 7 by 4 to get x. And that's going to be x is equal to 28. So I'll have 7 over 9 is equal to 28 over 36. And simplify that unsimplified fraction, and you will get 7 over 9 in that example. All right, 15 over x is equal to 60 over 8. So we can do, find the relationship between the numerators. So 15 times what is 60? That's going to be 4. So that means I'm going to multiply that x by 4 to get 8. So what number times 4 is 8? That's going to be 2. So I'll have 15 over 2 is equal to 60 over 8. Again, these are equivalent to each other. All right, last one. X over 14 is equal to 9 over 2. I'm given my denominators. So how would I get from 14 to 2? Well, I can divide by 7. So that's what I'm going to do over here too. I'll take x and I'm going to divide that by 7 to get 9. So what number divided by 7 is 9? That's going to be 63. So 63 over 14 is equal to 9 over 2.